We've talked about the trig functions in relation to the unit circle. Now we're going to talk about them in relation to triangles, specifically right triangles. So when we look at sine, cosine, tangent, cosecant, secant, and cotangent, you know the definition of these based on the unit circle. You know that in the unit circle, sine is the y value, cosine is the x value, tangent is actually y divided by x, cosecant is the reciprocal of the sine, secant is the reciprocal of the cosine, and cotangent is the reciprocal of the tangent. Now, they also have other definitions when we relate them to right triangles. And we're going to call this angle theta. So when I look at that angle, I have different pieces of this triangle. Since it's a right triangle, I have a hypotenuse, and the hypotenuse is the angle across from the right angle. It's the largest side of a right triangle. And then we have the two legs. And you are used to seeing these in previous classes. You know about the Pythagorean Theorem, which is c squared equals a squared plus b squared. And c is the hypotenuse. The legs are either the a or the b. It doesn't matter. But that's the relationship. So that if this were 3, 4, 5, 5 squared is 25. If I let a be 3, 3 squared is 9. 4 squared is 16, and 9 plus 16 is 25. So they have that relationship. So that's the relationship that we have in a right triangle. Now, sine, cosine, tangent, they have definitions based on their position in the right triangle. So in this right triangle, where I have this theta, this angle theta, since it's positioned in this corner, the side opposite from it is this one. The side adjacent to it would be this one down here. And of course the hypotenuse in the triangle is this side over here. So when I look at that angle, the definition of sine of theta is the side opposite of theta over the hypotenuse. So it's whatever this measurement is over whatever this measurement is. The definition of cosine is side adjacent over hypotenuse. And I'm abbreviating SA for side adjacent. And so here's theta. This side is the one that's opposite. Whoops. Let's go back and put that back where it was. This side is the side that's opposite. So this side has to be the side adjacent. Adjacent means beside. So that's the side that's beside it. Tangent of theta is the side opposite over the side adjacent. So if this is my angle, the side opposite would be this one, and the one beside it would be this one. So it's related to its position. Now, cosecant, secant, and cotangent are the same as they always were. Cosecant is the reciprocal of sine, so it would be hypotenuse over side opposite. Secant is the reciprocal of cosine, so it would be hypotenuse over side adjacent. And cotangent is the reciprocal of tangent, so it would be side adjacent over side opposite. Now that is something that you will need to memorize, and we'll do some problems in a minute. But you need to memorize this relationship, and sometimes people memorize things in various ways, but sometimes people remember these relationships by this word. Whoops. They'll do this. They'll use the word, and you've probably heard this before, SOHCAHTOA. Sine is opposite over hypotenuse. H stands for hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that's how some people memorize it, with the three main trig functions. Sometimes people remember it with a funny little story. Sum for sine, old for opposite, hippie, cot for cosine, another for adjacent, hippie for hypotenuse, tripping for tangent, on for opposite, acid for adjacent. So those are the three main trig functions, and then of course the other three are just the reciprocals of those, and that might help you remember those.